the bot got some moves too. So this is essentially the same full self-driving computer that runs in your Tesla cars, by the way.
This is literally the first time the robot has operated without a tether. It was on stage tonight. So the robot can actually do a lot more than we just showed you. We just didn't want it to fall on its face. So we'll show you some videos now of the robot doing a bunch of other things, yeah, which are less risky. Yeah.
We should close the screen, guys.
Yeah.
Yeah, we wanted to show a little bit more what we've done over the past few months with the bot, and just walking around and dancing on stage. Just humble beginnings, but you can see the autopilot neural networks running as is, just retrained for the bot, directly on that new platform. That's my watering can.
Yeah, when you see a rendered view, that's the robot. That's the world the robot sees. So it's very clearly identifying objects. Like this is the object it should pick up, picking it up. Yeah.
We use the same process as we did for autopilot to collect data and train neural networks that we then deploy on the robot. That's an example that illustrates the upper body a little bit more. Something that we'll try to nail down in a few months, over the next few months, I would say, to perfection.
This is really an actual station in the Fremont factory as well that it's working at.
Yep. So.
And that's not the only thing we have to show today, right?
Yeah, absolutely. So what you saw was what we call Bumble C. That's our sort of rough development robot using semi-off-the-shelf actuators. But we actually have gone a step further than that already. The team's done an incredible job. And we actually have an Optimus bot with fully Tesla-designed and built actuators, battery pack, control system, everything. It wasn't quite ready to walk, but I think it will walk in a few weeks. But we wanted to show you the robot, something that's actually fairly close to what will go into production, and show you all the things it can do. So let's bring it out.
Do it.
So here you're seeing Optimus with with the degrees of freedom that we expect to have in Optimus Production Unit 1, which is the ability to move all the fingers independently, to have the thumb have 2 degrees of freedom, so it has opposable thumbs, and both left and right hand, so it's able to operate tools and do useful things. Our goal is to make a useful humanoid robot as quickly as possible. And we've also designed it using the same discipline that we use in designing the car, which is to design it for manufacturing such that it's possible to make the robot in high volume at low cost with high reliability. So that's incredibly important. I mean, you've all seen very impressive humanoid robot demonstrations, and that's great, but what are they missing? They're missing a brain. They don't have the intelligence to navigate the world by themselves. And they're also very expensive and made in low volume. Whereas the Optimus is designed to be an extremely capable robot, but made in very high volume, probably ultimately millions of units, and it is expected to cost much less than a car.
I'll just bring it directly to the right here.
I would say probably less than $20,000 would be my guess.
Okay.